And we're recording on this computer. Everyone see it?
Yep, we're good.
Let's go.
All right. Hi, welcome to Group 6's Construction Methods project on development of AI optimization in on-site construction equipment. I am Eric Fiore, studying civil engineering with the depth area in structures.
I'm Dylan Ilov. I'm studying civil engineering with a depth in geotechnical engineering.
I'm Stanley Dean. I'm studying civil engineering with a depth in transportation.
Richie, studying civil engineering with a depth in structures.
I'm Daniel Francis, studying civil engineering with a depth in structures.
So, artificial intelligence is revolutionizing the way we live, as well as nearly every industry across the globe. AI is defined as the simulation of human intelligence in machines that are programmed to think, learn, and solve problems autonomously. It primarily uses the process of machine learning to solve problems, analyze data, automate processes, and much more. By now, most people have had experience with large language models such as ChatGPT or Google Gemini that specify in generating human language. However, the applications of AI go far beyond that. AI has already started to be implemented in the construction industry, specifically construction equipment, with using GPS and camera systems that connect to civil plans, doing things such as leveling roads and assisting crane operation. As AI evolves, lots of research and development continues to be done to find more ways to use AI to make construction safer, more efficient, and more cost-effective. In this presentation, we will describe how AI can be used with earthwork equipment, concrete mixing and distribution, and construction cranes to make these processes safer and more efficient. So our proposed applications of AI are earthwork equipment, which will use GPS and LiDAR systems linked to civil plans, as well as 3D printed concrete and distribution, where automated printing arm utilizing given dimensions and plans, and programmable mix design. And our last proposed application is construction cranes, where pressure sensors can detect environmental forces, counterweight system. They can counterweight system to counteract environmental forces, and cameras and laser sensing maps to surrounding area.
All right, so earthwork. Earthwork is an essential method that we use in the construction process. It involves moving soil and materials to create desirable surface for the building and the site layout that we're looking for. However, it's one of the most intricate, hazardous, and labor-consuming tasks that we see on construction sites. Whether it's excavation, compacting, grading, dozing, this process is usually very physically demanding, and it commonly breeds mistakes on the construction site, as well as involves a lot of supervision and manual labor. Gravis Robotics, that's a Swiss company, and they're leading the chase in autonomous excavation. They're developing an autonomous excavator that could make this idea actually become a real thing in the industry. Their autonomous excavator uses a combination of advanced technologies, a few of those being LiDAR, GPS, and GNSS. It allows to scan a site. It can download and understand CAD files, as well as following excavation plans with pristine accuracy. The machine transforms into its own operator. It automates the digging process based on the design specifications given in the civil plans. Their excavator prototype, you can see it in the middle picture, the one grabbing the rock. So while this idea is promising, full implementation is still pretty far off. Excavations are a really complex process, and the everyday conditions of a site are really unpredictable. Machines need to learn to adapt to variations in soil makeup. You never know whether you're working with clay and it's a rainy day, it can become very heavy and saturated, or you're working with fine materials or gravel or sand. It's whatever you're working with, it's always going to be different. The moisture content also plays a large part based on daily precipitation. And then there's also obstacles, whether you reach voids, obstructions, or whatever you may be. In excavation, you always can find what's been hiding underneath the ground for a long period of time. And also, all those processes require a lot of human surveillance. So as this method is implemented into the field, supervision is also going to have to be increased when AI is implemented as the operator steps out of the cab. So as you take one person away, you're going to have to add 2 people until this process is fully trusted. Currently, autonomous earthwork machinery, it's not yet ready to fully replace human oversight and all of excavation tasks, as I just explained. But on the other hand, tasks like soil compaction and grading are much easier to automate. Machines like dozers and rollers already have GPS systems that are used to follow site plans, perform leveling and compaction with fewer surprises. Current top of the market machinery and bulldozers already use GPS to grade sites to the nth degree. I've seen it with my own eyes. Trimble makes GPS attachments, as you can see on the top picture, that they hang on top of the dozer blade, and it can link with the civil plans to grade the soil completely. And that can happen because grading is more of a relatively uniform process, and it's a more feasible application for automation in the near term, as the fill material is usually placed before grading begins. So there's going to be less surprises and more just sticking to the blade being angled at a certain height. So ultimately, autonomous excavation and earthwork is still in development. AI and machinery is still learning how to better adapt to the dynamic nature of the construction site. While we're not yet at the point where we can fully automate earthwork tasks, we can expect to see more autonomous machinery working alongside human operators in the coming years to kind of see how they can sort of work together and kind of hand off the excavation and earthwork process from human to machine. So with doing that, you'll be able to improve accuracy, safety, and efficiency on the construction site. So as AI and robotics continue to develop in construction, we're moving closer to a future where automation becomes an integral part of earthwork, making the construction faster, safer, more efficient, and probably cheaper.
Okay, AI is revolutionizing the concrete industry by optimizing both mix design and distribution, leading to cost savings, improved accuracy, and greater efficiency. Traditionally, concrete pouring involves large amounts of manpower and machinery, often leading to inaccuracy and high costs. But with the advent of concrete printers and distributors, companies can now print concrete components on site, drastically reducing construction costs and improving precision. One of the key innovations in this transformation is Concrete Copilot. Concrete Copilot is an AI tool that was designed to optimize concrete mix design. Historically, designing the right mix for concrete involved trial and error, relying on standard formulas and months of experimentation to account for variables such as material availability, weather, and project specifications. Concrete Copilot changes this by analyzing vast amounts of historical data and project-specific requirements to create millions of possible mix designs. Within seconds, it selects the optimal mix, factoring in constraints like cost and material availability. This process not only saves time, but it also reduces the carbon footprint of concrete production. Engineers still maintain oversight, which allows them to make adjustments based on their expertise, but the AI handles the heavy lifting in terms of optimization. On the distribution side, construction robotics has developed several autonomous machines to assist with concrete-related tasks. Their semi-autonomous machine called SAM, which stands for Semi-Autonomous Mason, is capable of laying 3,000 concrete bricks in an 8-hour shift. This task would take human workers much longer. Additionally, robotics that enhance lifting capabilities allow workers to move up to 135 pounds with ease. These machines eliminate repetitive, labor-intensive tasks. They also enable humans to focus on more creative and decision-based aspects of the job, ultimately increasing both speed and quality on construction sites. With these technologies have already had a significant impact. There's still a long way to go before full autonomy is achieved. AI can increase efficiency and precision, but it lacks the creative problem-solving skills that humans bring to the table, especially when things in a project go off track. For now, the combination of human judgment with AI's computational power is proving to be the most effective approach. As the industry moves toward greater automation, the challenge will be to program AI to make decisions that are not only efficient, but also adaptable, simulating the ingenuity of human workers without sacrificing on precision. In conclusion, AI's role in optimizing concrete mix design and distribution is already making a noticeable difference in the construction industry. By automating time-consuming and repetitive tasks, it enhances accuracy, reduces costs, and promotes sustainability. As AI continues to evolve, the future of construction will likely be one where human creativity and AI efficiency work hand in hand, creating smarter, more efficient, and innovative ways to build.
One layer at a time, Vulcan prints a full house. It goes from the front of the slab to the back for one layer, and for these homes in particular, after 10 feet of printing in a few days, you have the wall system for a house. What you're seeing in front of you are layers stacked on top of each other, kind of one at a time. The feedback that we're getting from homeowners is how exciting it is to have a different choice in the material. So our different layers provide this kind of corduroy effect, which can actually be really soft and be a great experience for homeowners.
Now to talk about cranes. Currently, cranes are operated manually with an operator in the cabin. This presents a couple issues, including counterweight management, wind interference, and proximity challenges. Additionally, the high labor costs associated with crane operations are a significant burden. Despite these challenges, cranes are indispensable in the construction industry, as they are responsible for lifting and transporting heavy loads such as steel beams, concrete, and prefabricated elements. Moving these materials is crucial, but also poses risk, making safety a top priority. To mitigate these risks, construction companies and developers are increasingly integrating AI into crane operations. This involves the use of cameras, laser sensors, and pressure plates to enhance safety and potentially enable full autonomy. 360 cameras are a significant innovation that is ongoing and in developing use. These cameras provide a comprehensive view of the crane surroundings, allowing for the AI system to monitor and assess the environmental in real time. The panoramic visibility ensures that operators can make informed decisions, avoid collisions, and enhance the overall safety of the job. Along with the 360 cameras, photo laser sensors will also be used in assistance. Photo laser sensors play a crucial role in precise distance measurement. These sensors emit laser beams to detect obstacles and measure distances with high accuracy. This information is processed by the AI system to ensure that the crane operates within safe parameters, preventing accidents caused by close proximity to other objects or structures. Pressure sensors, or plates, are installed on the crane's arm to detect environmental conditions such as wind forces and other types of contradicting forces. These sensors provide real-time data on the load and crane system stability. If extreme winds cause swaying, the AI is able to adjust operations or halt activities to prevent accidents, ensuring a safer work environment. In conclusion, the integration of AI and crane operations is transforming the construction industry. With the help of cameras, sensors, and pressure sensors, cranes can operate more safely and efficiently.
Now to discuss feasibility. AI enhancements in earthwork, such as LiDAR GPS, bring significant improvements to precision, reduce manual errors, and save time in excavation and compaction processes. These technologies make AI-driven operations more feasible, especially in control environments where conditions are stable. However, challenges remain, including the high cost of implementation, the need for skilled operators to manage and maintain the AI systems, and the unpredictable nature of soil, which can complicate excavation tasks. Despite these obstacles, simpler operations like compaction are more practical for widespread use due to their predictability and consistent conditions, making them an excellent starting point for integrating AI in construction workflows. Concrete feasibility. AI's ability to automate concrete printing provides significant cost and time savings, particularly for large-scale projects. While upfront technology costs and the need for consistent material properties present challenges, the use of AI in concrete mix design and distribution is highly feasible in hybrid systems. These systems combine human oversight and the AI decision-making, ensure flexibility and reliability. Full autonomy in these processes remain a future goal, requiring advancements in the AI to handle field-specific variabilities more effectively. AI integration in cranes, like 360 cameras, pressure sensors, and other advanced tools, has already improved crane safety and adaptability in changing environmental conditions. These advancements make AI in crane highly feasible, offering better safety and precision. The choice between retrofitting existing cranes or investing in new AI-enabled systems will play a key role in how quickly and widely the technology is adopted. In conclusion, the integration of AI technology and on-site construction methods represents a groundbreaking evolution in the industry, addressing challenges like labor shortages, safety concerns, and efficiency bottlenecks. The advancement in earthwork equipment, automated concrete distribution, and construction cranes demonstrate the potential of AI. While these innovations significantly improve precision, speed, and worker safety, their implementation requires strategic planning to overcome limitations like high initial costs, reliability, and the learning curve associated with human-machine interaction. By bridging these gaps, AI has potential for revolutionizing construction processes, paving the way for more sustainable, efficient, and an innovative future.